Have you ever wondered if traveling through time and space is possible? As fantastical as it may sound, modern physics has introduced us to the concept of wormholes, theoretical passageways that could make such a journey feasible. Imagine, if you will, the fabric of the universe, a vast tapestry of space and time interwoven into what we call the space-time continuum. Now, imagine a wormhole as a tunnel, a shortcut through this fabric. Picture yourself standing on one end of a piece of paper and wanting to get to the other side. Instead of crossing the entire paper, you fold it, bringing the two ends together. The wormhole is that connection, the bridge that eliminates the distance. But what makes the idea of wormholes even more intriguing is their potential to enable time travel. The concept of time as a linear progression, a constant march forward from past to present to future, is deeply ingrained in our collective consciousness. But what if we could bend the rules? What if we could leap forward into the future or step back into the past? Theoretically, if one end of a wormhole is moving relative to the other, it could allow for such a temporal shift. A journey into the wormhole could spit you out at a different time, not just a different place. It's a mind-bending concept, one that challenges our understanding of the universe and our place within it. Of course, all of this remains purely theoretical at this point. Despite the math supporting their existence, we've yet to discover a real wormhole. And even if we did, there's no guarantee it would be stable enough or large enough for a human to travel through. But that doesn't diminish the fascinating possibilities they present. So buckle up as we delve deeper into this cosmic conundrum. By the end of this journey, you might just start to believe that time travel isn't just for sci-fi movies. Wormholes, despite their complex nature, can be simplified to a bend or fold in the fabric of space and time. As perplexing as this might sound, it's quite an easy concept if we use the right analogies. Picture a piece of paper representing our universe with 2 points on it. Now, the fastest route between these points in a traditional sense is a straight line, right? Well, not if we could fold the paper, bringing those 2 points into immediate proximity. This is the fundamental idea behind a wormhole, bending the space-time fabric to create a shortcut. Imagine punching a hole through the folded paper, creating a tunnel connecting the 2 points. This is essentially what a wormhole is, a tunnel through space-time. So instead of taking the long route, which could be billions of light years, we could simply step through the wormhole and come out on the other side, almost instantaneously. Now let's dive a bit deeper. The malleability of space and time is a consequence of Einstein's theory of general relativity. This theory tells us that mass and energy can warp the fabric of space and time, creating curves or folds. It's these folds that could, theoretically, become wormholes. But of course, it's not quite as easy as punching a hole through a piece of paper. A wormhole would need to be stabilized with a form of exotic matter or energy. This exotic matter, which we've yet to discover, would have negative energy density, preventing the wormhole from collapsing in on itself, allowing for safe passage. And when we talk about wormholes, we're not just talking about shortcuts through space. Because space and time are intrinsically linked, a concept known as space-time, a wormhole could also potentially be a shortcut through time. So a wormhole is essentially a cosmic shortcut, but what does that have to do with time travel? Stay tuned as we delve deeper into this fascinating intersection of physics and fantasy in our next segment. If wormholes are shortcuts through space, could they also be shortcuts through time? A thought-provoking question indeed. Let's delve into the fascinating realm of theoretical physics to find some possible answers. Einstein's theory of relativity, one of the pillars of modern physics, permits the concept of time travel through wormholes. But how, you might ask? The answer lies in the intriguing phenomenon known as time dilation. Time dilation is a difference in the elapsed time measured by two observers, due to a relative velocity between them or to a difference in gravitational potential between their locations. When you move at high speeds or are near a massive object, time can actually slow down. This time dilation is a key player in the possibility of time travel. Imagine you are in a spaceship traveling at close to the speed of light, while your friend is back on Earth. From your perspective, your clock on the spaceship is ticking normally, but when you look at your friend's clock back on Earth, it appears to be ticking faster. This is because time for you is moving slower due to the high speed of your spaceship. Now let's take this to the context of wormholes. Wormholes, in theory, can connect two different points in spacetime, effectively creating a shortcut through space. Now, if one end of the wormhole is moving at high speeds or is near a massive object, time at that end would be slower. This means that if you enter the wormhole from the slower end, you could emerge at the other end in what appears to be the past. However, it's important to bear in mind that these are highly speculative scenarios based on our current understanding of physics. There are numerous paradoxes and problems that arise with the concept of time travel, not to mention we have yet to discover a real wormhole, let alone traverse one. If time travel is possible, it seems like it would be more of a one-way trip. So, until we have more concrete evidence or breakthroughs in physics, the idea of time travel through wormholes remains in the realm of fiction, but who knows what the future holds. Stay curious, stay questioning. Imagine being able to peek into the future or revisit the past. That's the power of a wormhole. Let's dive a little deeper into the implications of this power. Time travel, as we know it, is a concept that is as fascinating as it is complex. It opens up a world of endless possibilities and countless paradoxes, which are enough to send even the most brilliant minds into a spiral of thought. Consider this: if you were to travel back in time and change an event, wouldn't that alter the course of history? This is known as the grandfather paradox. It's a hypothetical situation where a time traveler goes back in time and kills their own grandfather before the conception of their parent. This would prevent the time traveler's existence. If they don't exist, then how could they have killed their grandfather in the first place? Then, there's the butterfly effect, a concept that suggests even the smallest action can have significant effects on the future. Named after the idea that the flap of a butterfly's wings might ultimately cause a tornado, it's a stark reminder that every action we take could ripple through time, changing the course of history in ways we can't even begin to predict. So what could happen if we could travel through time? Would we be able to prevent catastrophes, or would our attempts only lead to other, unforeseen disasters? Could we avoid personal heartbreak, or would we only create new heartaches in the process? Time travel could potentially offer us a way to predict and shape the future, or to learn from and alter the past. But with such power comes great responsibility. It would require us to make decisions that could affect not only our own lives but the lives of everyone around us and generations yet to come. This potential to influence the future and the past is what makes the concept of wormholes and time travel so incredibly tantalizing. Yet, it also makes it incredibly frightening. After all, as the saying goes, with great power comes great responsibility. The power to alter time and space is both exciting and terrifying. So, can we start packing for our time travel journey yet? Well, you may want to hold off on that for a moment. Let's first delve into the current scientific consensus on wormholes and time travel. As it stands, the scientific community is divided. Some scientists are optimistic, believing that wormholes could be the key to time travel. Yet others are skeptical, arguing that the inherent instability of wormholes might pose insurmountable challenges. Wormholes in theory are shortcuts through the fabric of space-time. They could potentially allow us to leap across vast cosmic distances in the blink of an eye, or even travel back and forth in time. However, the reality is not as straightforward. The concept of wormholes comes from the field of theoretical physics, more specifically from Einstein's theory of general relativity. This theory suggests that wormholes could exist naturally in the universe. But here's the catch: these natural wormholes are predicted to be extraordinarily unstable. They would collapse instantly upon formation, leaving no time for anything to travel through. Overcoming this instability is one of the biggest challenges scientists face when thinking about practical time travel. It's believed that we would need something known as exotic matter to keep a wormhole open. This is a hypothetical form of matter with negative energy density and large negative pressure. However, the existence of such matter is purely speculative, and its discovery is still a matter of debate. Then there's the issue of energy. The amount of energy required to create a wormhole, let alone keep it open, is immense. Some estimates suggest it would be comparable to the energy output of a star. Harnessing such energy is, at least with our current understanding and technology, impossible. So, while wormholes and time travel make for great science fiction, the reality is a little more complicated. Theoretical physics provides us with fascinating concepts and ideas, but turning these into practical realities is another matter entirely. While we may not be able to travel through time just yet, the possibilities it presents are endlessly fascinating.